Okay, this is a review for test number 1 for spring semester for integrated 3. So let's get started. Number 1 says graph f of x equals 1 over x minus 2 plus 3. Name the asymptotes, the domain, and the range. Okay, so first I'm going to compare this graph. This is actually the simplest version of a rational function that we know. Okay, if you recall, a rational function always looks like this. F of x equals, this is the parent function. And then we can transform it into this form, 1 over x minus h plus k, right? Where h and k basically give you your asymptotes, okay? So if we look at this and compare it to the graph, we can see that h, a, and k, h is basically 2, not negative 2, right? It's x minus h, so it's x minus 2, so h is 2. A is simply 1, right? A is the number outside. There is no number outside, but there's a 1 on top, okay? So sometimes we write it like this with the A outside the parentheses. Sometimes it's just the number that is in the numerator of our rational expression here. So in this case, A is 1. And K is that number outside, right? So 3. Now, if you recall, H and B, which we're not looking at, there should be B there, affect the x-axis, x values, while A and K affect the y values. So H affects the x values. That tells you that the equation of one of the asymptotes is x equals 2. You can easily translate h equals 2 to x equals 2. Same thing for K. You can easily translate k equals 3 to y equals 3. Those are your two equations of your two asymptotes, okay? Which was what? This one is a vertical asymptote because it's a vertical line. This one is a horizontal asymptote because it's a horizontal line. So x equals 2, we'll go find 2 on your x-axis and draw a vertical line through there. Like that. Y equals 3, find 3 on your y-axis and draw a horizontal line through that. Those are my asymptotes. Okay. A is simply 1, which means that my graph is not changed. It's simply going to be 1, 1, and negative 1, negative 1. So like this, watch. Let's make our table. One, 1, negative 1, negative 1 is my parent function. Now I'm going to transform that to a new function using my h, a, and k. Okay. My h value basically is telling me to add 2 to all my x values. So I'm going to add 2 to everything. It's going to be 1 plus 2. Right? 1 plus 2 is 3. Negative 1 plus 2 is 1. And that's all that happens to my x values. Okay. For my y values, I'm going to multiply by 1, which is not going to do anything, but then I'm going to add 3. So basically add 3 to my y values. So 1 plus 3 is 4. And negative 1 plus 3 is 2. Plot those 2 points on your graph. 3, 4. Right there. And 1, 2. Right there. And there's your graph. Just connect those points using your asymptotes as a guide, knowing that my asymptotes are kind of like magnets that pull my graph towards them, but the graph never actually reaches them. And there's your graph. Okay, next what we need to do is find the domain and the range. I'm going to write the domain in all 3 forms that we learned, and the range as well. Okay, in interval notation, it'll look inequality notation. I mean, as an inequality, you would write it like this. Okay, the domain is going to be all the values. Now, before I actually go into it, remember that the domain are all the x values, right? What are the possible x values? And in this case, it's every single possible x value except for positive 2, right? Because that's your asymptote. The only possibility that doesn't work is positive 2. So what you got to do is say it's all the numbers before positive 2 combined with all the numbers after positive 2. So it's going to look like this. All the numbers before 2 or all the numbers after 2. So basically just not 2. That's inequality notation. In set notation, it's going to look like this. Let me try that again. All the values of x such that x does not equal 2. In set notation is usually easier because all you got to worry about is which are the numbers that don't work, which is 2. And finally, in interval notation, we're going to write it like this. All the values starting with negative infinity all the way up to 2, union with all the values from 2 to positive infinity. Now the range is very similar to the domain. It only has one excluded values in the range, right? The only value that we cannot use, remember range is the y values. The only one that doesn't work is positive 3 because once again that's an asymptote, right? Positive 3 is not a possible value in my range. So therefore my range is going to be all the values of y less than 3 or all the values of y greater than 3. In set notation, we're going to say all the values of y such that y does not equal 3. And finally, in interval notation is going to go from negative infinity to 3 and from 3 to positive infinity. Alright, so I'm going to let you guys try number 2 on your own. Go ahead and try it on your own. Start by identifying the asymptotes, right? Compare the graph to our regular general form. And then once you graph it, find the domain and the range as well. Write it in all 3 forms. Okay, go for it. Try number 2 on your own, on your paper. Try number 2 on your own and then come back, pause the video and then come back once you're ready to see the final answer. Okay, so here is number 2 completed. We're supposed to graph f of x equals negative 1 over x plus 1 minus 2. So I started by finding h, a, and k. H is negative 1, comes from the x plus 1 here. A is negative 1, which is this number up here. Sometimes, like I said, is written outside parentheses. And then k equals negative 2 because of the negative 2 right here. Using this h equals negative 1 and k equals negative 2, I came up with the asymptotes x equals negative 1 and y equals negative 2. Okay, and then I set up my parent function table, which is the simple one, 1, 1, negative 1, negative 1. That's 1 over x. That's the parent function. And I transformed it into this new function using these values. Okay, so for the x values, all I did was subtract 1 because that's h right there. So 1 minus 1, 0. Negative 1 minus 1, negative 2. For the y values, what I did is I multiplied first times negative 1, and then I subtracted 2. So 1 times negative 1, negative 1, minus 2, negative 3. Negative 1 times negative 1, positive 1, minus 2, negative 1. So using my 2 asymptotes, x equals negative 1, which is this one right here, and y equals negative 2, this one right here, and these 2 points, 0, negative 3, and negative 2, negative 1, I came up with this graph. And finally, the domain. For the x values, the only excluded one is negative 1, right, the asymptote. So x is less than negative 1 or x is greater than negative 1. In set notation, all values of x such that x does not equal negative 1. And then in interval notation, from negative infinity to negative 1 and negative 1 to positive infinity. For the range, the only excluded value is negative 2 because of the asymptote, right? So y is less than negative 2 or y is greater than negative 2. And in set notation, all the values of y such that y does not equal negative 2. And finally, in interval notation, from negative infinity to negative 2 and from negative 2 to positive infinity. Okay, here we go. Number 3. It says, write the function graph below in the form f of x equals a over x minus h plus k. Okay. first thing you got to do when you get one of these problems where they give you the graph and you're supposed to come up with the correct function is identify the asymptotes. I see a vertical asymptote here and I see a horizontal asymptote. Okay, so starting with my vertical asymptote, it looks like it passes through positive 3. So that is x equals 3. And then the horizontal asymptote looks like it passes through negative 1. So that will be y equals negative 1. That's basically your h and your k value right there, right? X, that's h equals 3, and k is negative 1. Substitute those into your function. Y equals, I changed f of x to y so that I could solve it, right? A over x minus 3, instead of h I wrote 3, plus k, so minus 1. Next, what you're going to do is come up with the x and a y value to substitute in so that you could find a. We don't know what a is, but they gave us a point we can use for our x and our y value. So that's what we're going to do. We're going to plug in 2 for x and 1 for y. So it's going to look like this. 1 equals, that's the y, 1, a over 2 minus 3 minus 1. Simplify that as much as you can. You're going to get 1 equals a over negative 1. Right? 2 minus 3 is negative 1 minus 1. A over negative 1 is just negative 1a. So 1 equals negative a or negative 1a minus 1. We're going to add 1 to both sides. And we're going to get 2. I'm going to continue over here. 2 is equal to negative a. Therefore, divide by negative 1 to cancel the negative 1. And a is equal to negative 2. So once you found a, you found h and k, go ahead and put those into your formula and you are finished. Okay, so my equation is going to look like this. F of x equals a, which is negative 2, over x minus h, which is 3, plus k, which is negative 1. And that is all. That is your final equation for this graph. Alright, let's look at number 4. It says the number n of daily visitors to a new store can be modeled by the function n equals 250x plus 1,000 all over x, where x is the number of days the store has been open. Part A, what is the horizontal asymptote of this function and what does it represent? Okay, so horizontal asymptote. What I'm going to do first is I'm going to rewrite this function. Let's do this in black. N equals 250x over x plus 1,000 over x. I can do that, right? Basically separated the two terms in the numerator all over the same denominator. And what that means is that cancels the x, so what I get is actually 250 plus 1,000 over x, which now I'm going to switch around and write as 1,000 over x plus 250. Now if I compare that to my regular function, which is supposed to always look like this, a times 1 over x minus h, the general form of my rational function, plus k, that means that k in this case is 250. And h is 0, right? H is 0 because there's no x minus h here, but k is 250. K is always going to be your horizontal asymptote, right? Y equals 250. So the horizontal asymptote of this function is y equals 250. What does that mean? What does that represent? Well, if you think about it, what that means is that you could plug in whatever number you want in here for x. Okay, x is the number of days the store has been open. So 20 days, 30 days, 40 days, 50 days. Plug in as many numbers as you want. What's going to happen is as x gets bigger and bigger, let's say you plug in 1,000, that's 1,000 over 1, which is 1. Plug in 10,000 and you get a decimal here, right? The bigger you make x, the smaller this little piece is going to get. But no matter what, you're never going to get a number that is less than 250. 250 is your limit, okay? So the average number of daily visitors to the store will never be less than 250. That is the limit. That's what it represents. Let's put that down. The daily visitors will never be below 250. Now part B, to the nearest integer, how many visitors can be expected on day 30? That's pretty simple. Day 30, we know that x represents the number of days, so just plug in 30 for x. We're going to get n equals, the number of visitors is equal to 250 x. Instead of x, we're going to plug in 30 plus 1,000 all over 30. Or you could use the other simplified version that we came up before, right? Either way, just plug in 30. And now just plug that into your calculator. So my calculator says 283.3, so we're going to round it to 283. On day 30, you can expect to have 283 visitors. Right, number 5, Joanna is organizing an outing with friends. They all want to go in the same vehicle. It will cost $2,000 to rent a van, and the cost for the event is $25 per person. How much will it cost each person if 8 people go? All right, so let's set this up. It's going to be $200 to rent the van. That doesn't matter how many people go. It's going to be $200. And then, in addition to that, you got to pay $25 per person. Let's call the number of people x. So plus 25x. That's the total cost. And how much will it cost if each person, if 8 people go? So the average cost will be the total cost, which is 200 plus 25x, divided by the number of people, which is x. Okay. So if x here represents the number of people, $200 plus 25 per person, that's the total cost, divided by the number of people, which is x, this will give me the average cost per person. And now what we're going to do is plug in 8 to see what we get. And at that point, it's just a calculator. Plug that into your calculator, and you get 200 plus 200 over 8, which is 400 over 8, which is 50. If 8 people go, it will approximately be $50 per person. Okay, number 6. Given f of x equals x minus 4 over x squared minus 4, find the domain in set builder notation. Set builder notation just basically means set notation. That's what we called it in class. Set builder notation, set notation, same thing. The whole, if it exists, the vertical asymptote, x-intercepts and y-intercepts, horizontal asymptote or slant asymptote if there are any, and then graph it. So everything we can find about this graph, and then finally graph it. Let's start with, first actually, let me factor this function as much as I can. So it's going to look like this. F of x equals x minus 4 over x squared minus 4. I notice that that is a difference of 2 perfect squares. So it's x plus 4x minus 4. And that basically gives me 2 excluded values, right? 2 discontinuities, which are negative 4 and positive 4. Okay? Now positive 4 and x minus 4 and x minus 4 here would cancel, which means that x equals positive 4 is a whole. And the other one, x equals negative 4, is a vertical asymptote. Let me repeat that again. This gives me x equals negative 4, right? That is not a whole because there is no factor like it on the numerator, right? You see repeated factors, numerator, denominator, that makes a whole. Since x plus 4 is unique, that means that x equals negative 4 is a vertical asymptote. But x minus 4 is not unique. You can cancel it, right? If you can cancel it, it's going to leave behind a whole. X equals 4 is a whole. Okay, knowing that, I can already find the domain, Right? Knowing that there's a hole at x equals 4 and a vertical asymptote at x equals -4, I know the domain already. Let me write it down. In set notation, all values of x such that x does not equal 4 or -4. Right? Those are the only excluded values for x. Let's find the found the domain, found the hole, found the vertical asymptote. Let's find the x-intercepts. The x-intercepts are real simple. To find the holes or the vertical asymptotes, you look at the denominator, you set each equal to 0. To find the x-intercepts, take the numerator, set it equal to 0. So if we set x minus 4 equal to 0, we should get an x-intercept, which is x equals 4. Now there's a problem with that though. X equals 4 cannot be an x-intercept because we said that it was a hole. If it's a hole, it can't also be an x-intercept. Okay, so there is no x-intercept for this graph. It does not touch or cross the x-axis. What about y-intercepts? To find the y-intercepts, just plug in 0 for x and see what you get. Right? Just like you do with any other function. Plug in 0 for x. If I plug in 0 right there, actually we can do it in our heads. If I plug in 0 right here and right here, I'm going to get -4 over -4, which is +1. So it's going to be y equals 1. That's your y-intercept. Let me repeat that again. Plug in 0 for x right here and right here. You're going to get 0 minus 4 over 0 minus 4, which is -4 over -4, which is +1. Okay. Horizontal asymptotes. Remember the rules. If the degrees are the same, let's start with that. Same degree over same degree. Then there is a horizontal asymptote at y equals a over b. That's the one you do that for. If the degree on the numerator is greater than the denominator, then there is no horizontal asymptote. Okay, HA does not exist. But there is a slant asymptote as long as the degree on the numerator is 1 greater than the degree in the denominator. That's not the case here. If the degree is greater in the denominator, like this, smaller degree over greater degree, then there is a horizontal asymptote always at the same place, y equals 0. And that is the case in this one, right? The degree in the denominator is greater than the numerator, so there is a horizontal asymptote at y equals 0. Okay, the last thing I'm going to do is make a table of signs so that I can figure out where my graph exists at different points. Okay, so here what I did right here is I set up a number line with my two important points, which are -4 and +4, right? That's my hole and my vertical asymptote. The x-intercept, it doesn't exist, but if we did have one, I would also include it here in my number line. Okay, since there isn't one, I don't have to include it. So what I do when I look at my number line is I notice how many different intervals are there. There's 1, anything before -4, 2, anything between -4 and +4, and 3, everything after 4, right? There's 3 pieces to my number line. So those are your intervals that you're going to put right here. Anything before -4, we're going to call that x is less than -4. Right? Does that make sense? Anything before -4. Anything between -4 and +4, we're going to call that -4 is less than x is less than 4. All the values between -4 and 4. And then anything after 4, we're going to call that x is greater than 4. So there are 3 intervals. And what you're going to do is you're going to pick a number that falls between those intervals, any value that falls within those intervals, and you're going to figure out what is the sign of each one of these 3 factors. These 3 things are basically these 3 things, right? After I factored it, x minus 4, x plus 4, and x minus 4 are the 3 factors of my function. So let's start. A number before -4. The easiest one I can think of is 5, right? So plug in negative 5 here. What you care about, you don't care about what you get, but what the sign is, right? Plug in negative 5. Negative 5 minus 4 is negative. Do it again. Same thing, right? Negative. Do it again. Here, negative 5 plus 4, negative again. So that's negative. Okay, not gonna finish it. I am not going to do this part. I'm going to do these 3 again and these 3 again for the next interval. So for the next interval, a number between negative 4 and positive 4. The easiest one I can think of is 0, right? So let's plug in 0 here, here, and here and see what sign we get. So 0 minus 4, that's going to be negative. 0 minus 4, that's going to be negative again. And 0 plus 4, that's going to be positive. Now let's do it again for this last one. A number greater than 4. How about 5? So 5 minus 4, that's going to be positive. 5 minus 4, that's also going to be positive. And 5 plus 4, that's going to be positive. And now what you're going to do here is figure out what the final sign will be. Combine these 3 negatives together. What's your final sign going to be? Negative. Right? Think multiplication. Negative times negative times negative, negative. Combine these 2 negatives and a positive. What's going to be your final sign? Positive, right? Negative and negative make positive, and another positive, still positive. And the last one is going to be positive. Okay? And now we can put it all together into our graph. Okay, so let's start with the vertical asymptote. X equals negative 4. So I'm going to draw a vertical asymptote. X equals negative 4. Right here. A horizontal asymptote at y equals 0. I'm going to draw that. Horizontal asymptote at y equals 0. Like that. There are no x-intercepts, but I know that there's a y-intercept at y equals 1. So I'm going to put that one right there. Let's do that one in red. Right? What else do I know? I know there's a hole at x equals 4, but that doesn't help us much right now until we know what the shape of the graph is going to be. Once we know the shape of the graph, we could then erase the point that it passes through at x equals 4, right? And leave a hole in its place. So next what I'm going to do is use my table of signs. What my table of signs says that at any time before negative 4, so before this point, the graph is going to be negative. So it's going to exist down here. And I pretty much know what the shape is going to be, right? My asymptotes are magnets that pull the graph towards it. So it's going to go something like that. Next, my table says that between negative 4 and positive 4, my graph is positive. And it continues being positive after 4 as well. Okay, so I think I have an idea of what the graph is going to look like. It's going to be positive everywhere from negative 4 on. It's always going to be positive, right? So it's going to go something like this. Except the only thing that we have to worry about is that hole, right? There's a hole at x equals positive 4. So right here, 1, 2, 3, 4, right here, there should be a hole in your graph. So I'm going to erase right there to leave a hole in my graph, like that. There you go. That's the shape of your graph. So notice how we put everything together, okay? I started by factoring the function. Using the denominator, I found the holes in the vertical asymptotes. There was a hole at x equals 4 and a vertical asymptote at x equals negative 4. Then I used the numerator to find any x-intercepts. I didn't find any because it gave me the same value as the hole, so it can't be both, right? Then I found the y-intercept simply by plugging in 0 for x, and I got positive 1. I found the horizontal asymptote by comparing the degrees. Since the degree in the denominator was larger, that means that the horizontal asymptote is y equals 0 every single time. Then I use a table of values in my intervals using x equals negative 4 and positive 4, these two, as my dividing parts of my graph. and I figured out what the sign of the graph was going to be before -4, between -4 and +4, and after +4. Using that and these factors, I figured out that the sign was going to be negative, then positive, then positive. So that's what I found out my graph. I put everything together, my asymptotes, my y-intercept, and my knowledge of what the graphs always look like to put these two together. And the last thing I did was leave a hole right here at x equals 4, because that's what this tells me right here. Okay, so let's do it all again. I'll go a little bit faster on this one. Now that you saw number 6, you should be able to understand it a little bit easier. So here we go. It says given f of x equals x squared plus x minus 6 all over x squared minus 5x plus 6. Find the domain, the hole, if it exists, the vertical asymptote, the x-intercepts and y-intercepts, the horizontal asymptote or slant asymptote, and then graph it. So everything we did in number 6. Let's start by factoring first. Okay, so I'm going to write this in factored form. F of x equals x squared plus x minus 6. Go ahead and factor yourself. You know how to do that. Okay, I'm going to go ahead and just show you what the factored form is going to be. It's going to be x plus 3x minus 2. I don't think I have to slow down to explain how I got that. If you're confused, just check how you're factoring. It should be those exact factors. The denominator is going to be x minus 6 and x plus 1. No, scratch that. That's wrong. It's going to be x minus 2, x minus 3. Yeah, that seems right. Okay, so then to find the holes or vertical asymptotes, just look at the denominator. Okay, come up with the two discontinuities, which are x equals 2 and 3, right? X does not equal 2 or 3, actually, because they are discontinuities. Now, 2, you can see that it's the same factor in the denominator as in the numerator. That means it's a whole. So x equals 2 is a whole. 3, x minus 3 is not repeated. It's not the same. See how it's different? So since it's not the same, that is a vertical asymptote. Using those two values, I can write my domain already. All values of x such that x does not equal 2 or 3. Okay, for the x-intercept, you're going to take the numerator and set them both equal to 0. So you can do that in your head. X plus 3 equals 0 gives you negative 3. And x minus 2 equals 0 gives you positive 2, right? So x equals negative 3 and positive 2. But there's an issue with positive 2. We already said it's a whole, so it cannot be an x-intercept also. Okay? It can't be both. So then the only x-intercept is negative 3. So x equals negative 3. To find the y-intercept, you're going to plug in 0 for x. Okay, everywhere you're going to plug in 0 for x to see what you get. So look at this right here. You could probably do this in your head as well. Plug in 0 for x here and here. You're going to get negative 6. Plug in 0 here and here. You're going to get positive 6. So at the end, you're going to have negative 6 over positive 6, which leaves you with negative 1. Your y-intercept is y equals negative 1. You know what, I'm going to rewrite the x-intercept and the y-intercept in coordinate pair form. So it's going to be negative 3, 0 and 0, negative 1 for the y-intercept. I just don't want it to look like this because that looks like a vertical asymptote or a horizontal asymptote, right? But it's the same thing. Okay, horizontal asymptote. The horizontal asymptote, you're going to compare the degrees of the numerator with the denominator. Since the degrees are the same, you can see that x squared over x squared. That means that your horizontal asymptote is going to be y equals a over b. Every time the degree is the same, that's your horizontal asymptote. A and b in both cases are both 1, right? A and b are your leading coefficients. So 1 over 1, which is 1. So your horizontal asymptote is y equals 1. So that's your horizontal asymptote. So there you go. We found most of the stuff we needed to find. We're going to use all of that for our graph. Okay, next thing I'm going to do is make my table of signs here. I've already set up my number line right here with -3, 2, and 3 as my important values, right? Those came from the whole, the vertical asymptote, and the x-intercept, right? -3 is the x-intercept, 2 and 3, 2 is a whole, 3 is a vertical asymptote. Using those three as my values, important values on my number line, you can see that I've divided up the number line into 4 pieces. 1 before -3, 2 between -3 and 2, 3 between 2 and 3, and the last piece, the fourth piece after 3. So there's 4 pieces, 4 intervals that I'm going to write right here. And then I've set up my signs for my factors. Notice that I've only set up 2 factors here, x plus 3 and x minus 3. Why did I do that? To make my job a little easier. What's going to happen with x minus 2 and x minus 2? They're going to cancel. So since they're going to cancel, there's no need for me to also include them here. Okay, that's something you can use to make your job a little bit easier and faster. Okay, so here we go. Let's set up the intervals. All the values before -3, we're going to call that x is less than -3. All the values between -3 and 2, we're going to call that -3 is less than x is less than 2. All the values between 2 and 3, we're going to call that 2 is less than x is less than 3. And finally, all the values after 3, we're going to call that x is greater than 3. And now we're just going to choose values that fall within those intervals and figure out what the sign is going to be. Okay, so first, something before -3, something less than -3. How about -4? So plug in -4 here, -4 plus 3, you're going to get a negative. Plug in -4 here, -4 minus 3, you're also going to get a negative. Now pick a value between -3 and 2. 0 seems the easiest option here. So let's plug in 0. 0 plus 3, positive. 0 minus 3, that's negative. All right, next, something between 2 and 3. How about 2.5? 2.5 plus 3, that seems positive. 2.5 minus 3, that's negative. All right, and finally, a value that is greater than 3, something after 3. How about 4? 4 plus 3, that's positive. And 4 minus 3, that's also positive. So what are my final signs? Let's look. Negative, negative, that makes positive. Positive, negative, that makes negative. Positive, negative, n, that's negative. And positive, positive makes positive. Okay, and finally, we're going to put it all together in our graph. Okay, there's a vertical asymptote at +3. There's a horizontal asymptote at y equals 1. Like that. There is an x-intercept at -3, 0. Right there. There's a y-intercept at 0, -1. So you kind of already see what the shape is going to be like, right? It says in our table that before -3, the graph is positive. But after -3 and before 2, the graph is negative, right? So positive, before this point, it's positive. That's what's basically happening, right? It's going to cross the x-axis and be positive. But after that point, it's going to be negative every single time, okay? So we can actually graph it already on this side. It's going to be positive on this side, and then negative, and negative, and negative, and so on. According to my table of signs here, after 2 and before 3, it's still negative. So after 2 and before 3, so at this point, it's still negative. Obviously, looks like it's always going to be negative from that point on. But after 3, it's back to being positive. So after this asymptote, it's positive again. The only way that could happen is if the graph is over here. Like that. And the last thing I need to worry about is that hole, right? There's a hole at x equals 2. So x equals 2, right here, there's supposed to be a hole. So I'm going to erase this little piece right here to leave a hole in its place. Like that. There's your final graph. Alright, let's do it again. Number 8. Very similar, except this was a little different because it will not have a horizontal asymptote. It will have a slant asymptote. So I want to make sure I show you guys how to do that. Okay. So first, once again, like in the other ones, I'm going to write it in factored form. So it's going to be f of x is equal to, I'm going to factor the numerator, x plus 2, x plus 2. Trust me on that one. You can do that yourself. I know you know how to do that. And the denominator is just x minus 1. So using that denominator, x minus 1, that gives me the discontinuity, which is x equals 1. Actually, x does not equal 1, right? And that is a vertical asymptote because you can't cancel it, right? So x equals 1 is a vertical asymptote. There are no holes. So using that, I can come up with a domain already. All the values of x such that x does not equal 1, right? Which is your vertical asymptote. X-intercepts, look at the numerator. Those two values, x plus 2, x plus 2, each one of them gives you an x-intercept. So x equals negative 2. I'm going to write it in coordinate order pair form, so negative 2, 0. And that one is an actual intercept because it does not contradict the holes or the vertical asymptotes, right? So that number is the only x-intercept. Y-intercept, plug in 0 for x and see what you have left. If I plug in 0 here and 0 here, in the numerator all I will have left is 4. If I plug in 0 in the denominator, I will have negative 1. So 4 divided by negative 1 is negative 4. The y-intercept is negative 4. As an ordered pair, 0, negative 4, right? That's the way we prefer to write it. So actually, I don't like it in this form or this form because it looks like asymptotes. All right, horizontal asymptote. If you compare the degrees, the degree in the numerator is larger than the degree in the denominator. That tells you that there is no horizontal asymptote. Every single time that happens, there is no horizontal asymptote. However, you can see that the degree is exactly 1 larger than the denominator, right? Its degree is larger just by 1. When that happens, that means there is a slant asymptote. There has to be a slant asymptote, and we're going to find it right now. You find it in this form. You're going to take the numerator, and you're going to divide it by the denominator. Whatever you get up here as your quotient, that is your slant asymptote. Okay, so let me erase this just to make space. So here we go. X times what gives you x squared? X, right? So x times x is x squared. X times negative 1 is negative x. So what we have is x squared minus x. But we're going to subtract that like we do for long division. This cancels. 4x minus negative x. Be careful here. 4x minus negative x. That means 4x plus x. So that's 5x. Bring down the plus 4 and do it again. X times what gives you 5x? 5. So plus 5. Take that 5, multiply times both of these. You're going to get 5x minus 5. But you're going to subtract that, which is what we do. 5x minus 5 cancels. 4 minus negative 5, that means 4 plus 5, that means 9. And there's nothing else you can do. At this point, you're done. This is what you care about, the x plus 5 up here. That is your slant asymptote. Whatever you get when you divide them into each other, your quotient, don't worry about the remainder, your quotient is your slant asymptote. So my slant asymptote is y equals x plus 5. Okay, I'm going to erase all this to do the graph. Okay, next what I'm going to do is set up my table of signs here. As you can see, I set up my number line over here using my two important values, which is my vertical asymptote x equals 1 and my x-intercept, which is -2. Using those two, you can see that I split up the number line into three pieces, right? Anything before -2, between -2 and 1, and everything after 1. I've also set it up for my three factors. I made sure I include x plus 2 twice because it's not going to cancel. They're both in the numerator, so I have to include them both. Okay, so my intervals, anything before -2, that's x is less than -2. Between -2 and 1, so -2 is less than x is less than 1. And then after +1, so x is greater than 1. And now what you do, as always, is choose a value that falls inside that interval and plug it in here to see what sign you get. So a value before -2. How about -3? Plug in -3 here, we're going to get negative. In the next one, we're also going to get negative. And in the next one, plug in -3, we're going to get a negative. Next, a value between -2 and 1. 0 seems the easiest option once again. So plug in 0 here, that's positive. Plug in 0 right there, that's also positive. And plug in 0 in the last one, and that's going to be a negative. And last, a value after 1. How about 2? Plug in 2 right here, you're going to get a positive. Plug in 2 in the next one, you're going to get a positive again. And plug in 2 in the last one, you're going to get a positive again. Combining those signs together, in the first one, negative, 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 that's going to be a negative. The next one, positive, positive, negative, that's going to be a negative again. And the last one, positive, 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 that's going to be positive. There you go. Now I'm ready to graph it. Okay, so let's start graphing it. I'm going to start with the vertical asymptote, x equals 1. So x equals 1 is a vertical asymptote. Right there. Next, I am going to graph the x-intercept, which is -2. So it's going to cross the x-axis at -2. The y-intercept is -4, so it crosses the y-axis at -4. Right there. And next, I'm going to graph the slant asymptote. So this is something that some of you guys might find confusing because you haven't been doing it that much. But this is basically a line, right? Y equals x plus 5. Remember algebra 1, y equals mx plus b. So we're going to begin at +5, and then the slope is 1, so up 1 over 1. So it's going to look something like this. Begin at +5, 2, 3, 4, right here. And then the slope is up 1 over 1, so it's going to go up like that. Down 1 over 1 as well. That is a slant asymptote. And finally, what I'm going to do is take my table of signs to figure out where my graph exists. Okay, so looking at my table of signs, any time before -2. So here's -2. Before -2, my graph is negative. See that? It's going to be negative. It's going to exist on this side. Between -2 and +1, my graph is still negative. So that means that my graph never actually crosses the x-axis. It just touches it, right? So it's negative before here, and then before -1, it's still negative, so it's going to be negative the entire time. It's never going to actually cross over there. It's going to touch and come back down and cross through there, like this. And notice that the slant asymptote is going to continue going like that. So my graph is actually going to approach that asymptote. Let me try that again. So it's not going to cross at -2. It's just going to touch the x-axis and come back down. And then it's going to approach the slant asymptote like that. Then my table of signs says that after 1, after my vertical asymptote, it's going to be positive. And this point you have to be careful. Since I have two asymptotes, one going like this and one going like this, and I already drew this piece down here, the other piece must be way up here. Okay, so let me show you guys what that means. Let me erase this table because it's getting in the way right now. But what I know is that the graph is going to be positive after my vertical asymptote, right? So let me stretch my vertical asymptote. It's going to keep going like that. My slant asymptote is going to keep going like that. Since I just drew this piece right here, the other piece has to be up here. There's no other option. It has to be there. It can't be here as well, right? Remember, they're always on opposite sides of our asymptotes. So it's going to look something like this, approaching both asymptotes. Okay, I'm going to let you guys try number 9 on your own. Go for it. Try everything that we just did. Find the discontinuities. Tell if they're holes or vertical asymptotes. Find the x-intercepts, the y-intercepts. Find the domain as well once you found the asymptotes or the holes. Find the horizontal asymptote if there is any, or if not, the slant asymptote, and then graph the whole thing. Okay, go for it. Try it on your own. Come back once you're ready to see the final answer. Okay, so here we go. I found everything for you. The vertical asymptote is x equals -1 because of the denominator. There are no holes. The domain is all the values of x such that x does not equal -1. The x-intercept is x equals 2/3. That comes from the numerator, right? Set it equal to 0, you get 2/3. The y-intercept, plug in 0 for x, you're going to get -2, so 0, -2. The horizontal asymptote is y equals 3 because the degrees are the same, so it's a over b, so 3 over 1. And there's no slant asymptote. Then I did my table of signs here. The intervals are -1, anything before -1 because of the vertical asymptote, between -1 and positive 2/3 because that's the x-intercept, and then after 2/3. Using these two factors, which are basically the numerator and the denominator, I came up with positive, negative, positive for my signs. Okay, so let's put it all together and graph it. The vertical asymptote first, that's x equals -1. The horizontal asymptote, there is one, it's y equals 3. The x-intercept is 2/3, that's 0.666666, so somewhere around here. Approximately, right? It's not exact. The y-intercept is -2, so right about there. That pretty much gives me the idea of what it's going to look like, but using my table of signs, you can see that before -1, it's positive. Here's -1, so it's going to be positive, so I know it's going to be up here. Between -1 and positive 2/3, it's negative, so it's right here, negative, between -1 and positive 2/3. And then after 2/3, it's positive again, so it crosses over to the positive side, which makes sense right here. So it's going to be like this. On this side, it's always positive, approaching the asymptotes. And on this side, it's negative, 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 negative. At this point, it becomes positive. It crosses over into the positive side. And there are no holes to worry about in this one. Okay, number 10, rewrite the rational expression in simplest form and state the excluded values. Basically telling me to subtract these two. Okay, so here we go. It's going to be x over, every time you get one of these problems, factor, factor, factor. I'm going to go ahead and factor. It's going to be x minus 3, x plus 1. You know how to factor that. I don't have to go through the entire factoring process, right? Minus the other rational expression is going to be 3 over. Now if I factor that, I'm going to get x minus 3 and x minus 4. Okay? Using those two things, I know that the LCD, the least common denominator, is going to be x minus 3 times x plus 1 times x minus 4, right? X minus 3 times x plus 1 times x minus 4. I do not write x minus 3 again because it's included in both of the denominators. So if that is my LCD, what I want is for them both to have the same denominator. So I look at this first one and say, What's missing from this one so that the denominator could be this? And you could see that it's missing the x minus 4, right? So we're going to multiply times x minus 4 over x minus 4. So this is what it looks like, right? This is what I have, but I'm going to multiply by x minus 4 over x minus 4. For the other one, it's 3 over x minus 3 x minus 4. What's missing from that one so that it could have this denominator? So it's missing, it has the x minus 3, it has the x minus 4, it's missing the x plus 1, right? So that one I'm going to multiply times x plus 1 over x plus 1. So what you're going to have, you're going to distribute the x times those two. It's going to get x squared minus 4x, right? X squared minus 4x over x minus 4, x minus 3, x plus 1 minus 3 times x plus 1, that's going to be 3x plus 3. 3x plus 3 in the numerator over x minus 4 times x minus 3 times x plus 1. Same denominators. Now that they both have the same denominator, I'm going to continue working over here. Now that they both have the same denominator, I can put them together like this. X squared minus 4x, and here's what you got to be careful, minus 3x minus 3. Repeat that again, because there's a minus here, I have to subtract both of these. So it's going to be minus 3x minus 3. The denominator is basically our denominator that we want, x minus 4 times x minus 3 times x plus 1. Now combine like terms in the numerator. You're going to have x squared minus 7x minus 3 all over x minus 4 times x minus 3 times x plus 1. And finally, the last thing you should attempt to do is to factor this to see if anything can cancel with the numerator, with the denominator. X squared minus 7x minus 3, I don't see anything that can be factored. You can try, right? You can do the x factor if that's the way you do it, or you factor it however you know how to do it. See if you can cancel something. If it doesn't, if nothing cancels, then you're done. If something cancels, then go ahead and do it. At this point, I'm done. I know that this is not factorable, so this is my finished final answer. A lot of times what people want you to do is to multiply these three out to get a denominator that's also in standard form, but this is fine with me. As long I can see that you found the common denominator and you have your numerator and you combine all the like terms. This is okay. Alright, let's try it again. Number 11. Rewrite the rational expression in simplest form and state the excluded values. Okay, so once again, I'm going to rewrite these. First, what I'm going to do is rewrite them all as fractions. That's 4 over 1 plus x over 1. Using those three denominators, I know that my LCD is going to be x minus 5. Times 1 times 1, right? So it's not going to make a difference, just x minus 5. Since I want that to be my denominator, it's pretty easy to see that this one I need to multiply times x minus 5 over x minus 5. And this one I need to multiply times the same thing, x minus 5 over x minus 5. This one already has that denominator, so there's nothing to do with it. Just leave it alone. So this is what you're going to have. 2 over x minus 5, that's the first one, minus 4 over 1 times x minus 5 over x minus 5. Because I wanted to have the same denominator. Plus x over 1 also times x minus 5 over x minus 5. See that? Simplify that down or multiply it out and you're going to get 2 over x minus 5 minus 4x minus 20 All I did here was multiply the 4 times the x into the negative 5 over x minus 5 plus x squared minus 5x over x minus 5. Now that they all have the same denominator, I can put them all together. So it's going to look like this. 2 minus 4x plus 20. Notice what I did there. 2 minus 4x plus 20. Because of the negative here, these two is negative 4x and positive 20. Plus x squared minus 5x. All over the same denominator, which is x minus 5. Combine like terms in the numerator. It's going to be x squared minus 5x minus 4x is minus 9x. And positive 20 and 2 makes 22. All over x minus 5. And again, the last thing you should try to do is see if you can factor this to see if anything can cancel. X squared minus 9x plus 22 is not factorable, so that means that we are done. Oh, you know what I've been forgetting to do is to state the excluded values. Okay, so let's do it in this one. We didn't do it in the one before. The excluded value comes from the denominator, right? The original denominator, which is x plus 5, and any new denominators you might have, which is the same thing in this point. So there's only one excluded value, which is 5. X does not equal 5 is my excluded value. Right? That's the only value that would not work. Let's go back to 10 real quick to state the excluded values. The excluded values for 10 are 4, 3, and negative 1. Right? The three factors that are in the denominator. There you go. Okay, so that's it for 10, 11. Go ahead and try number 12 on your own. Okay, so start it right now on your own paper. Try it, then come back and see what the final answer is. So pause the video. Okay, so here's the answer for number 12. I started here with 3x over 2x minus 3 minus 6x over 2x plus 3, 2x minus 3 because I factored 4x squared minus 9 plus 1 over 2x plus 3. Then I figured out that the LCD, I wrote it right here, the LCD is 2x plus 3 times 2x minus 3. So that means that this one is perfectly set up already, but this one is missing a 2x plus 3, and this one is missing a 2x minus 3. So that's why I multiplied it times those two things. Now in this one, on the left side, I distributed the 3x, got 6x squared plus 9x over 2x plus 3, 2x minus 3. This one stayed the same, and this one, 1 times 2x minus 3 just becomes 2x minus 3 over 2x plus 3, 2x minus 3. Now that they all have the same denominator, I put all the numerators together. So 6x squared plus 9x minus 6x plus 2x minus 3. I combined like terms, and I got 6x squared plus 5x minus 3. As always, the last thing you should do is try to factor this. Okay, if this is factorable, do it and then cancel. This is not factorable. You can try. 6 times negative 3 is negative 18, but there are no numbers that make negative 18 but add up to 5. Okay, so that's your final answer. The excluded values, before I forget again, are going to be positive 3/2 and negative 3/2. Those are your excluded values right there. Alright, so for number 13, go ahead and try it on your own, just like number 12. Right? Do it yourself and then come back and see the final answer. Go for it. Okay, so here's the final solution to number 13. I started here, 2x over x minus 6x plus 1, because I factored x squared minus 5x minus 6. Then, right here, what I noticed is that I had 6 minus x, which is very similar to x minus 6. So what I did is I factored out a negative 1, which you can do, and turned it into x minus 6. Right? Factor out negative 1 and you get negative 6 plus x, which is basically the same thing as x minus 6. And then what you can do with this negative 1 is bring it to the top. So you have minus a negative 3, right? And minus a negative 3 just becomes positive. And that's how this turned into plus 3 over x minus 6. Okay, and that's going to make my problem much easier to finish. Then I notice the LCD is x minus 6 times x plus 1 because it has that same denominator on this side. So since the LCD is x minus 6 times x plus 1, the second fraction is just missing the x plus 1 part. So I multiply it times x plus 1 over x plus 1 so that they have the same denominator. I get 3x plus 3 because it's 3 times x times 1. And then I put them together, 2x plus 3x plus 3, right here, over the same denominator. 2x and 3x make 5x plus 3, and so that is my final simplified expression. I can't factor anything else or cancel anything, so that's going to stay like that. And my excluded values are positive 6 and negative 1. Alright, number 14. Perform the operation and state the excluded values. X cubed over plus 27 over x squared minus 9 divided by 6x over 7x minus 14. I am going to start by, before I factor, I'm going to start by turning this problem into a multiplication problem. Right? Instead of division, multiply. And it's going to be 7x minus 14 over 6x. Division is basically multiplication times the reciprocal, right? And now what I'm going to do is factor everything I can factor so that I can see what I can cancel. Okay, I'm going to start with the easy one, which is this one. That's just 7 that is factored out, right? 7 and then x minus 2 over 6x, which there's nothing to factor there. Another easy one is the denominator over here, x squared minus 9. That's basically going to be x plus 9, x plus 3, x minus 3. Like that. And now the numerator, that's the one that's going to take you a little while to factor out. Because you should be able to see that that is the sum of two perfect cubes, right? X cubed is a perfect cube, and 27 is a perfect cube. It's 3 times 3 times 3. Right? So if that is the sum of two perfect cubes, remember the pattern for two perfect cubes. It goes like this. You're going to have two factors in this, two terms on this one, 3 terms on this one. Okay? And the first one is just going to be whatever the cube root of the first term is, which is x, and whatever the cube root of the second term is, which is just 3. And you're going to always keep the same sign. Okay? In the other part, in this part, the first term is this one squared. Always. Whatever this is, squared. So x squared. The last one, the last term, is the second term, also squared. So that's 9. And the middle one is going to be multiply these two times each other, 3 times x. And the sign of that one is going to be negative because it's always going to be the opposite of whatever this sign was. So that this x plus 3 times x squared minus 3x plus 9, that is the numerator over here. So I'm going to draw it over here. I'm going to write it over here. X plus 3, let's squeeze it in here. It's barely going to fit. X squared minus 3x plus 9. Okay? And now all we have left to do is to cancel as much as we can. Everything that we see that can be canceled, cancel it. You can cancel the x plus 3 and the x plus 3 here. And that's it. Nothing else cancels in this case. X squared minus 3x plus 9 and x minus 3 in the denominator, the 7 and the 6x, the x minus 2, nothing cancels. Okay? So your final simplified form is 7 times x minus 2 times x squared minus 3x plus 9 all over 6x times x minus 3. It's completely factored, nothing else to simplify. Now if you see that it's actually multiplied out, then go ahead and multiply it out, but that's fine for me. What are the excluded values? The excluded values come from all of the denominators, okay? So you look at the denominators here in the original, but you also look at the denominators here after you did the reciprocal of the second fraction, right? So my excluded values come from here, which is x squared minus 9. So that's going to be x does not equal positive 3 or negative 3. Also, 7x minus 14 gives me an excluded value, which is 7 times x minus 2, so x equals 2. That's another one. And then also, right here, when I put the 6x in the denominator, that gives me another excluded value, which is 0. So there are 4 total excluded values. All right, you try 15 on your own. Go ahead and try it. Factor, cancel, do everything that I just did. Don't forget that you're supposed to change this to multiplication by doing the reciprocal here. So go ahead and try it. Pause the video. Come back once you're done to check your answer. Okay, so here we go. Number 15. So for the first one, the first thing I did is factor out a negative 1 so that I could write it like this. Oops, let me do it in red. I factor out a negative 1 so that I could write it like this, x squared minus 25. You don't have to do this step, but I'd always like it to be in standard form, right? So if you factor out negative 1, you get negative 25 plus x squared, which is the same thing as x squared minus 25. And then you could factor that as x minus 5x plus 5. The denominator is not that difficult. Just factor that out. You're going to get x minus 5 and x minus 2. On the other fraction, I first turned it into multiplication, and then I did the reciprocal, as you can see. So for this denominator here, I did the same thing I did up here. I factor out negative 1 so that I could put it in standard form. Because otherwise it would be negative x squared. It would look like this. Negative x squared minus 2x plus 8. I didn't like that, so I factored out negative 1 to turn it into positive x squared plus 2x minus 8. Okay, and so that's how I got this. I factor out negative 1, and then I factor the other part, which ended up being x plus 4, x minus 2. And the denominator is just negative 12. Okay, at that point I canceled, and you can see that what's going to cancel is the x minus 5 here and the x minus 5 there, the x minus 2 and the x minus 2 there. So what's left in the numerator is a negative 1, x plus 5, another negative 1, and an x plus 4. In the new denominator, just negative 12. Then I multiply the negative 1 times the negative 1 to cancel them out. That becomes positive 1, so they're basically gone. So x plus 5 over x plus 4 over negative 12. Or you could take that negative and write it in front and write it as negative x plus 5 times x plus 4 all over 12. Right? Or also you could also just multiply them out. But that's as simple as it's going to get. What are the excluded values? The excluded values are going to be, using our original problem, it's going to be positive 5 and negative 2, no, positive 2 as well, positive 5 and positive 2. And right here, there it doesn't give you an excluded value, but here it does, which is this numerator here, which is going to be negative 4 and positive 2 again. So negative 4, and I don't have to write positive 2 again because it's an excluded value anyway. Those are your excluded values. All right, I'm going to let you try number 16 on your own first, and then once you're tried it, come back and check your final answer. I'll get you started though. What I want you guys to do when you see something like this, it looks confusing. It really is not. It's the same thing we've been doing. Focus on this middle division sign right there. Right? If you focus on that, you can write this as 4x squared plus 2x minus 2 over 3x plus 3 divided by, that's the middle division sign right there, divided by 2x squared plus 5x minus 3 all over 3x plus 9. Right? If you see that, the fraction over a fraction, just focus on that middle division fraction bar and turn it into a division symbol, and then write the two fractions separately. Right? Go ahead and try it on your own. Pause the video, do it on your own, then come back and check the answer. Okay, so number 16, here we go. This is the final answer. I factored 4x squared plus 2x minus 2 first by taking out the GCF, which is 2, and then what was left was 2x squared plus x minus 1, which factors into 2x minus 1, x plus 1. 3x plus 3 is basically 3 times x plus 1. Right here, the second fraction, remember, turn it into multiplication and then do the reciprocal. So this is the numerator, which is 3x plus 9, which turns into 3 times x plus 3 after factoring. This numerator is now the denominator, which you can factor into 2x minus 1 times x plus 3. At that point, you should be able to see that there are a lot of stuff cancels, right? The 2x minus 1 and the 2x minus 1 cancel. The x plus 1 and the x plus 1 cancel. The x plus 3 and the x plus 3 cancel. And also this 3 and this 3 cancels, leaving you with basically just 2. That is what's left after all those divisions. And then what are the excluded values? Negative 1 came from here, 1/2 came from here, and negative 3 came from here. You also got to take into account the original denominator here, which is 3x plus 9, but that also gives you x plus 3, which is negative 3. So it gives you the exact same excluded value. And that's your final answer. All right, 17, solve the equation, check for extraneous solutions. 6x minus 5 over 2x minus 5 equals 3x plus 1 over x minus 4. First thing I'm going to do is find the LCD. Factor as much as you can. There's nothing to factor here, right? So the LCD is basically 2x minus 5, which is the denominator of the first fraction, times x minus 4, which is the denominator of the second fraction. So if you want that to be your denominator, you got to look at that first one and say, what's missing from it to turn it into this LCD? It's just like adding and subtracting fractions. So what's missing is x minus 4. That means that you need to multiply that 6x minus 5 over 2x minus 5 is going to be multiplied by the missing factor, which is x minus 4 over x minus 4. The other one equals 3x plus 1 over x minus 4. Ask the same question. What's this one missing so that the denominator is this? So it has the x minus 4. It's missing the 2x minus 5. So you're going to multiply that one times 2x minus 5 over 2x minus 5. And so what you're going to have left is this. Multiply in the numerators, right? Multiply in the numerators, which is going to give you x minus 4 times 6x minus 5 equals 3x plus 1 times 2x minus 5. What happened to the denominators? Well, since they're all the same, they sort of just cancel, right? The denominators are all the same, so that means that the numerators are the same. All right, right here what I'm going to do is I'm going to FOIL. I'm going to multiply it all out. So this is going to be 6x squared. Follow me along as I FOIL. Right, 6x squared minus 5x minus 24x plus 20 equals, let's FOIL on the right side as well, 6x squared, 3x times 2x, 6x squared, minus 15x, 3x times 5, right, times negative 5, plus 2x minus 5. All right, what's going to happen here is the negative 5x and the negative 24x are going to get together. So it's going to be 6x squared minus 29x plus 20 equals 6x squared minus 13x minus 5. And you want to put it in standard form, right? Because it's a quadratic, so you're going to solve it by factoring or by quadratic formula. So you want to leave this in standard form. You got to move everything over to the left side. So if I'm going to move everything to the left side, I'm going to subtract 6x squared. I'm going to add 13x, and I'm going to add 5, because that will cancel each one of those three pieces. So I'm going to subtract 6x squared. I'm going to add 13x, and I'm going to add 5. Alright, I'm going to continue over here. So 6x squared minus 6x squared is going to cancel right here. Negative 29 and positive 13 is going to be negative 16x. Positive 20 and positive 5 make positive 25. And on the right side it's just 0. Alright, and to finish it, we're going to subtract 25. Negative 16x equals negative 25. Divide by negative 16. And x equals positive 25 over 16. There you go. Now just compare that to your excluded values, right? From the beginning, we didn't write them down, but our excluded values come from our original denominators. So my excluded values are x does not equal 5 over 2 and 4. So since those do not contradict each other, that means that x equals 25 over 16 is an actual solution. It is not extraneous. Okay, so there are no extraneous solutions, only an actual real solution. All right, let's do one more together, and then you guys will basically do 19 and 20 on your own, okay? So 18, solve the equation, check for extraneous solutions once again. So first, before I forget, I'm going to do what I forgot to do in number 17. I'm going to go ahead and find the excluded values right now. So my excluded values come from my two denominators, which are x minus 4, which gives me 4. And 4 minus x also gives me 4. So that's the only excluded value that I have. Right? So if I get a solution that says x equals 4, then that's extraneous because it doesn't, it contradicts my excluded value. All right, now let's find the LCD. If I put this over 1, my LCD is going to be x minus 4, and that's it. Notice that it's x minus 4 and 4 minus x. Can I write that 4 minus 6? Watch, let me show you guys what I'm doing. This is 2 over 1 is equal to 1 over x minus 4 minus 3 over, can I factor out negative 1 and write it as x minus 4 instead of 4 minus x? Yeah, you can, right? And you should, because you want them to be the same, and that makes it much easier for them to be the same. And then what you can do is this negative 1 and this negative in front, you can just write it as plus. So it's going to look like this. 2 over 1 equals 1 over x minus 4 plus 3 over x minus 4. And your problem is so much easier now. So if the denominator is x minus 4 on the right side, I can put those two together, okay? My LCD is just x minus 4, which means that my first fraction over here is just missing that denominator. So I'm going to multiply it by x minus 4 over x minus 4. The other ones don't need any multiplying. They're ready. It already have the denominator that I want, x minus 4. So the one on the left side, distribute the 2. You're going to get 2x minus 8 over x minus 4 equals 1 over x minus 4 plus 3 over x minus 4. And now that all your denominators are the same, they can cancel out. And so what you have left is, I'm going to continue here, 2x minus 8 equals 1 plus 3. So 2x minus 8 equals 4, right? 1 plus 3. We add 8. At this point, it's really easy to finish, right? 2x equals 12. Divide by 2. And x equals 6. Compare that to your excluded value. It's not the same thing. Therefore, that's your solution. X equals 6. So notice a little trick that I used on this problem to make my problem easier, right? I noticed that 4 minus 6 is the same thing as x minus 4, just with the negative 1 factored out. So I wrote it as negative 1 times x minus 4. And then this negative 1 and this negative right here together make a positive, right? Or you could think of it as moving the negative upstairs to the numerator, so it's negative 3. Minus negative 3 just becomes plus 3. And now that the denominators are the same, all I had to do was turn this into the same denominator by multiplying times x minus 4 over x minus 4. And that gave me this. The denominators cancel, and it became a very simple equation to solve. All right, you try number 19. As before, try it on your own first, please, before you finish watching the video, okay? So struggle with it. Once you think you have it or you got stuck, then come back and see the video, okay? So pause the video now and do it on your own. So here we go. The correct solution for number 19 is x equals negative 19 over 3. Here's how I got to that point. I wrote the last fraction on the right side as 2 over x plus 3 times x minus 3. So then I noticed that the LCD is going to be x plus 3 times x minus 3. So that means that this first fraction is missing the x plus 3 part, and this one is missing the x minus 3 part. So that's what I multiplied in times, x plus 3 over x plus 3, x minus 3 over x minus 3. I distributed and I got 9x plus 27. On this one I got 3x minus 9. This one stayed the same because the denominator is already what we wanted. When all the denominators are the same, they canceled out right there. And that's how we're left with 9x plus 27 equals 3x minus 9 minus 2. Combine like terms and solve. At the end, it's actually a very simple equation. I get 6x equals negative 38, which means that x equals negative 19 over 3. And that is an actual solution because my excluded values were 3 and negative 3, and so they don't contradict each other. So your solution is x equals negative 19 over 3. Alright, so once again, number 20, try it on your own. Negative 5 equals 8 minus x over x squared minus 11x plus 24. Go ahead and try it. Pause the video right now. A hint I can give you is put that 5 over 1 so that you can solve it, and then factor everything. First thing I see right away, actually, before I let you guys do it on your own, is the 8 minus x. I'm going to factor out a negative 1 there and write it as negative 1 and then x minus 8. Right? And it's going to make your job probably easier at the end. So go for it. Pause the video now. Come back to check your answer. Okay, so here's the solution for number 20. Hopefully it didn't trip you guys up too much. So I started with negative 5 over 1. I factored out negative 1 from the 8 minus x to get x minus 8. And over here I got x minus 8 and x minus 3. Right? The x minus 8 and x minus 3, a way that you could do this much faster than what I did, I found the LCD, right, which is x minus 8, x minus 3. So I multiplied both sides times x minus 8, x minus 3. And I got x minus 8, x minus 3 times negative 5, x minus 8, x minus 3 times 1. So I got this as my numerator and this as my numerator because the denominators canceled out. I multiplied it all out and I got negative 5x squared plus 55x minus 120 equals negative x plus 8. I moved everything to the left side to put it in standard form, so plus x. So 55x plus x is 56x, negative 120 minus 8, negative 128. And then I went ahead and factor out negative 1 of this one to make it positive, and then I factored this 5x squared minus 56x plus 128, which is factorable, turned into 5x minus 16 and x minus 8. And then these two give me my two solutions, which are 16 over 5 and 8. But 8 is an excluded value from before, right? Because of my denominator is x minus 8, x minus 3. So 8 is excluded, 3 is excluded. Therefore, this cannot be a solution. So the only solution is x equals 16 over 5. X equals 8 is what we called an extraneous solution, right? That's an extraneous. Let me show you guys a different way that you could have gone that you would have found the correct solution much faster. Okay, if you recall factoring and canceling, then you could have just went ahead and canceled the x minus 8 here to turn it into negative 5. This is what you would have. Negative 5 over 1 equals negative 1 over x minus 3. And that would have been a much easier problem to solve, right? Find the LCD and solve it. But it would have just given you this solution, not this one, because it would have canceled. Okay. But if you didn't see it, that's fine. You don't have to go that way. Go the way with the LCD, and you should end up with the same solution with the extraneous solution of x equals 8. Alright, and finally 21. An artist is designing a picture frame whose length L and width W satisfy the golden ratio, which is W over L equals L over L plus W. If the length of the frame is 24 inches, what is the width of the frame? So it's basically asking us to plug in 24 for L and solve for W. Okay, so it's going to look like this. W over L, which is 24, equals L, which is 24, over L, which is 24, plus W. And we're supposed to solve for W. We want to leave it all by itself. Okay, so I'm going to start like I always do by finding the LCD. In this case, the LCD is going to be 24 times 24 plus W. Right? It's not just 24 plus W. You have to include this one and these two together because of the plus sign right there. So if I want that to be my LCD, this one is missing 24 plus W. So I'm going to multiply it times 24 plus W over 24 plus W. W over 24 equals 24 over 24 plus W times, what's that one missing? That one's simply missing 24. So 24 over 24. There you go. So this one I'm multiplying times 24 plus W over 24 plus W. This one I'm multiplying times 24 over 24, and that way will give me the same denominator for both. Okay, multiply it out. On the left side, you're going to get 24w plus w squared over 24 times 24 plus w equals 24 times 24, which is 576, over 24 times 24 again, which is, well, actually, I'm just going to leave it as 24 times 24 plus w. Because now the denominators are the same, I can cancel them out, leaving me with, I'm going to put it in standard form, w squared plus 24w equals 576. Move the 576 by subtracting it, so you're going to get w squared plus 24w minus 576 equals 0. We're going to factor that. I think 576 is factorable. Or actually, you know what? I don't think it is. 576. No, it's not. You can try to factor. I don't think it's going to work. 576. No, it doesn't. I'm going to go ahead and do the quadratic formula here. So it's going to be w equals negative b, negative 24, plus or minus the square root b squared, which is 24 squared, 576, minus 4a, which is 1c, which is negative 576, all over 2 times 1. Simplify that down. I get negative 24 plus or minus square root of, inside the radical I have 576 plus 4 times 1 times 576. A calculator tells me 2304 all over 2. So negative 24 plus or minus radical 576 plus 2304 is going to be 2880 all over 2. And at this point, just use your calculator to estimate, get a decimal approximation. Calculator says that radical 2880 is approximately 53.66. So negative 24 plus or minus 56.66 all over 2, which leaves me with positive or negative. I'm going to scroll out here. It's going to be negative 24 plus 56. My calculator says that that's going to be approximately 16.33 or negative 40.33, depending on if you use the positive or the negative. Since we're talking about the width of a frame, the negative one here makes no sense. So I'm going to get rid of that negative one. So that means that only the positive one makes sense, which is 16.33. It is not excluded, right? The only excluded value here was negative 24. That's not negative 24. So W equals 16.33 inches. If the length is 24, the width is approximately 16 1/3, 16.33. And that's your final answer. All right, this concludes the review.